Assalamualaikum and hello everyone. We continue with chapter summary for chapter 3, physics chapter 3 for the second semester, that is electric current and direct current circuit. So we have quite a lot of subtopics for this chapter. It's basically we have 9 subtopics to be discussed for this chapter. So we start with 3.1. 3.1 is explaining the electric current. So the current is actually the rate of change of the charge flow, okay, because of the charge, we have the charge here, and how fast or how slow it is flowing, it is telling us about the quantity of current. So current is in the unit of ampere. Then we have the charge. The equation of charge can be written as NE. N is the number of electrons, because hopefully you still remember that the charge that is flowing in the wire is actually electron, so that's why we multiply with the number of electrons. Then the second subtopic, you have Ohm's law. Ohm's law basically tells us the relationship between voltage and current. If the voltage is increasing, it is the current will be increasing, so they are directly proportional. In terms of equation, the resistor here, the resistance here is the factor that give us this relationship of V against I. So V is equal to IR. The unit for resistance is ohm. Then we also have the resistivity. So resistivity is related to type of material of the wire. Okay, so different wire will have a different resistivity, because it is depending on the resistance, area, the cross-sectional area of the wire. This is a cross-sectional area, and also the length of the wire. So the unit for resistivity is ohm meter. So from this equation, you can also rearrange that equation. Then you can have the equation for resistance, resistivity L over A. Okay, and for 3.3, we have variation of resistance with temperature. The basic concept here is that if you increase the temperature, the resistance will increase. They are directly proportional. So it is related to the atoms in the wire or in certain material. When the temperature is increasing, this atom will vibrate, and when it is vibrating, the motion of the electron in between these atoms will be limited. So when the electron cannot easily move, meaning that the resistance is high. So that's how we have the R is directly proportional with T. So this is the equation that relates R for certain temperature. So R is for T, R naught is for T naught. And alpha here is the coefficient of the friction. It depends on the material we are referring to or we are using for certain case. Okay, as we know, just now we have R is equal to rho A over L. Then from here, R is directly proportional with resistivity. Hence, we can also have the equation R. The same pattern of equation, instead of writing R, we can write in terms of resistivity. That is 3.3, and then we have 3.4. So for 3.4, we have electromotive force, EMF, internal resistance, and potential difference V. Okay, so in this case, we consider EMF is from the battery. So we assume this is our battery. So in the battery, we have the internal resistance, and the internal resistance exists because of the chemical content of the battery. So we cannot see our internal resistor with our naked eye, and because of there is an energy dissipated or power dissipated, or we say here is a voltage drop, power loss in this internal resistor when the current is flowing, meaning that your V, your potential measured at this external resistor, will be less than the EMF. So EMF is the potential of the battery. V here is the potential measured at the external resistor. So we have an equation. Why do we have less value of voltage? Because battery EMF is equal to voltage across the external resistor plus voltage across the internal resistor. And the current flowing for this both resistors are the same, so we can factorize the equation. Okay, and that's how you get the multiple type of equations for EMF. Okay, so for your information, voltage here is also known as voltage across this battery or voltage across this external resistor. We call it as VT. So it is also known as terminal voltage. For 3.5, we have the arrangement of series and parallel of the resistors in a circuit. So basically for 3.5, we want to have the effective or total resistance. If you combine all the resistors in a circuit, what will happen to the effective resistance? And also we can calculate the term. When you know the resistance, you know the rule of current flowing, then you can also calculate the voltage, as we have V equal to IR. So we need to consider what happens to voltage, what happens to current, what happens to resistance. Let's focus at this series arrangement. So this is the series arrangement of resistors. We have 3 resistors in series. So when they are in series, the current are the same. The current total, okay, is equal to current across resistor 1, resistor 2, and resistor 3. But for the voltage, it is not equal for all the resistors because they are in series. Because what happened here is when the current flow at this first resistor, there will be a voltage drop. Then the current that is flow out from resistor 1, we have less voltage. Then voltage drop here and also voltage drop here. So the total voltage here is equal to V1 plus V2 plus V3. And from equation V equal to IR, we are deriving this equation. We substitute. So we can have this equation of R effective for series arrangement. Okay. For parallel arrangement, it is the other way around. So the current will add up all together to get the total current, but the voltage are the same for all resistors in parallel. So again, using V equal to IR, we derive from this current equation. Then you will have the term for effective resistance for parallel arrangement. For 3.6 is basically about Kirchhoff law. Kirchhoff law is used when we have a complicated circuit or complex circuit. So what does it mean by complex circuit? It means that when you have a circuit with more than one battery, okay, more than one battery or more than one EMF. So if you have that type of circuit, you need to apply Kirchhoff rule to solve the circuit, normally to get the value of current flowing in that circuit. The question may also ask you to get the voltage, to get the resistance in that circuit. So the most important equation to use for Kirchhoff law is this one, current in, current out at any junction. And we have another 2 equation that we need to apply, that is Kirchhoff's second rule, that is summation of E equal to summation of IR. So normally we'll have loop 1. If you have 2 loop, so you need to deduce one equation for summation of E, summation of IR. Loop 2, and again you have to deduce summation of E equal to summation of IR. So there are certain rules to be obeyed to have this equation for the 2 loops. So the first one is, if you have the direction of loop equal to the direction of EMF, the direction of EMF is from negative to positive. We draw it next to the symbol of the battery. Then if they are the same, okay, meaning that your value of EMF is going to be positive. But if it is different, the value is negative. Same goes for the term of IR. If you have the current flow in the circuit in negative, this is current, this is the direction of loop. So if they are in opposite direction, your term here must be negative. And if they are having the same direction of loop is the same direction as the direction of current, so your term here, IR here, must be positive. So that is Kirchhoff law. Then for 3.8, you have potential divider. So basically potential divider is for if you want to have certain portion of voltage in your circuit. Let's say you have resistor 1, resistor 2, total voltage from the battery. So let's say we just want to get the portion, just part of the uh, resist part of the voltage here. So we need to adjust so that we have only the term voltage across resistor 2. We control the resistance. So we have here the equation supposed to be V. For example, we have here V2. So if we want to get V2, here supposed to be R2, and here supposed to be R total. R total is R1 plus R2 times the V total. Okay, you can also express this equation in terms of length, because resistance is directly proportional with the length. That is 3.8. 3.9 is potentiometer. So the concept of potentiometer is actually applying the concept of potential divider. Okay, you have E1, E2. So E here is more or less equal to V1 and V total. L1 is L1. L2 is L1 plus L2 is L total. Okay, we have a more complicated calculation for potentiometer, but you have to go. So potentiometer 3.8 is the last subtopic of this chapter. So that's all for chapter 3. Thank you very much.